Hi everyone, this is section 7.2 from our Hawkes College Algebra textbook, and we are going to talk about the application of exponential functions today. Okay, so the first problem that our book is going to give you, for example 1, is a biologist is culturing bacteria in a large petri dish. She begins with 1,000 bacteria and supplies sufficient food so that for the first 5 hours the bacteria will population grows exponentially. If the population doubles every hour, how many bacteria are there after 2.5 hours, or after she begins? So we're going to look at this book, and I'll work it out the way they do in the book. And sometimes, like this book, I think does it, I don't want to say differently. They make it easier to follow, I think. But there are, if you look at videos on this, they may show you a little bit different way. So again, don't there's different ways to do things. So this is one way to do it, and it's not a bad way, it's a good way. But the like if you find videos on YouTube, they might be a little bit different. So we have to consider all parts of the all different ways you can do it. Okay, so when we think about our problem, a lot of it we can do in our head. We know we start with 1,000 bacteria, and it doubles every hour for at least the first 5 hours where they have sufficient food. So we know at the beginning, we started off with 1,000 bacteria. We know after 1 hour, we're going to have 2,000. After 2 hours, we'll have 4,000. And after 5 hours, it will end up being 32,000 bacteria. But we want to know 2.5 hours. So it's a little bit different. And you can't just say, well, I know after 2 hours, there's 4,000. So that means, after 3 hours, I'm going to have 8,000. So I'm going to say there's going to be 6,000 bacteria after 2.5 hours. It's a good estimate, but it's not always exact. So we do need to create a problem to find our answer. All right, so the problem that we're going to use, or the formula we're going to use, is going to be P of t, or is equal to P times a to the t power. Now, P of 0, that is the initial population. So we're going to get what the population equals. Sometimes they call this A over here, or capital A for, the amount after a certain time. But we're writing it as a function, so P of t, the population after the time. So our initial population, P of 0 in our case, is 1,000. And then we know at 1 hour it's 2,000. So we know it doubles every hour. A is your growth rate, or like the base of your power. If it doubles every time, RA is going to be 2. So we're going to write an equation. Our P of t is going to be equal to our initial population of 1,000 times 2, and then t is your time. So we want 2.5 hours. So that's our equation that we're going to calculate to find the bacteria after 2.5 hours. Now, let's say you're not sure what A should be. You don't know. They maybe say it, it doesn't double. You're not sure what A should be. You're not sure what you should use for that base. What you can do to solve that, and I'm going to show you so that you can see, is we know we have enough information. I know, again, P of 1 is 2,000. So what I could do is I could write an equation. If I make P of 1, we know P of 1 equals 2,000. So I could write an equation. I can do 2,000 is equal to our initial population of 1,000 times A to the first power. And again, because we have that 1 for the exponent, that's going to give us A. So all I have to do here really to solve is divide by 1,000 to get A to the 1 first. By itself, excuse me. And that is going to give me 2,000 divided by 1,000 is 2. And that equals A to the first power, or A. So again, if you don't know A, it's one way to find it. We know it doubles, so that's a 2. But that's not always the case. So it's one way you can use this to find it if you need to. But we're going to calculate this equation right here. So when I calculate that equation, the first thing I'm going to do is I'm going to do 2 to the 2.5 power. And then it's going to give me a long decimal, but I'm not going to round it at all. I'm going to leave it as is, and I'm going to times that by 1,000. You could probably put it all in at once, but I don't like to do that because I feel like it makes it, sometimes it gets it off a little bit. So if we want to know the time after 2.5 hours, so P of 2.5, when I plug in that 2.5 for my power, and I believe they asked us to round to the nearest whole number. So what I get when I do my initial calculation, this 5,656.854249, and again, I'm writing everything. But if I'm rounding to the nearest whole number, I'm going to make it 5,657 because that's an 8, so that means I would round up. So there would be 5,657 bacteria in the Petri dish. That's after 2.5 hours. And again, earlier I said we could estimate 6,000. It was kind of close, but it wasn't quite the same. So here is our actual answer. All right, another formula we're going to look at is one where we look at compounding interest. When you compound interest, that means when you are getting interest, when you have money into a bank account, if you get compounding interest, what it means is when you calculate your interest in your bank account, let's say you put $500 in, and the first month you earned $2 in interest. So the amount in your bank account would be $502. The next month, if you do compounding interest, when they calculate the interest, they're going to calculate it not only on the $500 in the account, but also the interest you earned. So you'll get interest on $502. So that means you may earn, like $2.05 in interest or something around there. But compounding interest calculates interest on the principal or the amount you put in. Principal is going to be our P, so that's what you put in. It is also, they talk about, like, you have an interest rate, so that's your interest rate right there, R. N is the number of times per year that it's calculated. I was just talking about every month, so that would have been monthly, so that would have made N 12. Sometimes it's calculated yearly, which makes N 1, or semi-annually would be twice a year. Quarterly would be 4 times a year. So however many times you get interest per year, that's going to be N. And then T is the number of years, and they always count it in years. So if you get something where they give it to you in months, you want to convert those months into years. So T is your time in years, and that's how we would do our compound interest formula. And we're going to take a look at an example in the next. Okay, so here we have Sandy, and she is going to invest $10,000 into a savings account earning 4.5% annual interest compounded quarterly. So that means that her interest rate is 4.5% compounded quarterly. So every time she gets interest, they're going to calculate it at that 4.5% rate. What is the value of her investment after 3.5 years? So I want to calculate how much money she will have in her account after 3.5 years. So we are going to use our compounding interest formula. So we're going to use, A of T is equal to P, which again is your principal, how much you put in, times 1 plus the rate divided by the number of times compounded, and all of that is raised to the NT power. So when we find our equation, we are doing, our time is 3.5 years, so 3.5 years. And let's see here, principal, how much she invests. She invests $10,000, so we'll put our $10,000 in there. The 1 represents the total amount you've put into the account, 100% of the money in the account, plus then when you do your rate and the number of times compounded, that's when you're adding in the extra money. Now our rate is 4.5%, but when you put it into your equation, you never put it in as the 4.5%, you have to put it in as a decimal. So remember that 4.5, you move the decimal point over 2 places. So you put in 0.045. N is the number of times compounded. It is compounded quarterly, so that means 4 times a year. And then our NT, so it's going to be 4 times, and then our interest rate is going to be, or not our interest rate, our time is 3.5 years, so 3.5. And then we're going to use our calculator to calculate this. So what we are going to do first is, I always like to do my exponent. I don't want to have that multiplication problem hanging out there. So I'm going to do 4 times 3.5. It gives me 14. So what I'm going to do in the blue is I'm going to cross this out. I just multiplied it and I made it 14. All right. Now, order of operations. Remember, you got to do parentheses first. So I'm going to do our 45 thousandths divided by 4 and add 1. And again, never with these problems, you never want to round until you get to the very end. So sometimes you get a crazy decimal on your calculator. Keep it all. I happen to have this time, it's 1.01125. So it's not too bad. But then I'm going to multiply that times the 10,000. Oh, wait, excuse me. I'm not going to multiply that times my 10,000 first. I have to raise this to the 14th power. So I'm going to do 1.01125. Raise that to my power because that power is outside those parentheses there. And when I do that, now I have this. I have 10,000 times 1.169551862. And again, you never want to round it because then you're skewing your numbers a little bit, and you'll find the more you round, the more your answers will vary from what we get in here. And that could mean, if you're calculating some bank money or interest you're earning, you could be shorting yourself some money, or, sometimes the bank, if they round too much, they give you too much, which is good for you, but not good for the bank. So again, powers, parentheses first, exponents. So I did the 1.01125 to the 14th power. Now I'm going to multiply that times my 10,000. And that is going to give me, at the end of the 3.5 years, in my bank account, I am going to have $11,695. And then it gives me this nice long decimal, which I'm going to talk about it in a second. We're going to round this to money. So we're going to have $11,695. And because that's an 8, we're going to round to the hundredths, so it'll be 52 cents. Okay. So after 3.5 years, I have $11,695.52 in my bank account. Okay, so for our next example, it's going to be a little bit different than our first one, because here we have Frank, and 9 months after depositing $520 into a monthly compounded savings account, Frank checks his balance and finds the account has $528.84. Being the forgetful type, he can't quite remember what the annual interest rate for his account is supposed to be, but he sees that the bank is advertising a rate of 2.5% for new accounts. Should he close out his existing account and open a new one? So we're going to take a look at this and figure out what his interest rate is. And again, we're going to use our compounding interest formula. So A of T equals P times 1 plus the rate divided by N, or the number of times compounded raised to the NT power. And what we need to do is fill in what we know. I know my principal amount is $520. That's what he put into the account. And let's see here. I need to find the rate, so we're going to leave our R there. N, the number of times compounded. It is monthly compounded, so that's 12 times a year. And when we do our NT power up here, N is 12. Now T is always in years. We have 9 months. So again, I said before, you have to convert it to years. That's like having 9/12, or you could simplify that. You could divide it. It becomes 0.75, or it's the same as having 3/4. So either way, 3/4, you could do 12 times 3/4 or the decimal equivalent 0.75. And then that we need the 528.84. That is after the 9 months. That's how much he has in his account. So that's our answer. Kind of running out of room there. Okay. So now we need to solve this. What I'm going to do first is do 12 times the 7/500. Okay. So instead of that, this is what I have. I have $528.84 is equal to 520 times 1 plus the rate divided by 12 to the 9th power, because I did 12 times 0.75 and I got 9. So now, really what we need to do is we need to, first what I'm going to do, the 9 is connected to the parentheses. I'm going to get rid of the 520 by first I'm going to divide both sides by 520. And that, when I do that, if I take $528.84 and divide it by 520, all right, I'm going to end up with 1.017 is going to be equal to, my 520s will cancel out, so it'll be 1 plus r divided by n. I'll write that in red so you can see it, to the 9th power. Now, really what we want to do is we want to get rid of that 9th power next. So if something's raised to the 9th power, then we have to take the 9th root of everything. So I'm going to rewrite it over here. I have 1.017 equals 1 plus r divided by n to the 9th power. But what we're going to do is we're going to take the 9th root of both sides. So on my calculator, I'm going to have to go to math, and I'll go to option 5, and I'll do the 9th root of 1.017. And that, again, you don't want to round. It's going to give you a crazy wonky answer, but we're going to have 1.00874.768 is equal to 1 plus r divided by, not n, but 12. Okay, because our 9th root's canceled out there. Now, we got to get our rate, so we're going to subtract 1. So now I have 0.001874768 is equal to r divided by 12. We want r, so if it's divided by 12, we are going to multiply both sides by 12. And when I do that, we are going to end up with, all right, I multiply by 12, so I have 0.022497218 equals r. We want an interest rate. So again, this is a decimal. We're going to turn it into an interest rate. To do that, move your decimal point over 2 places. So we have roughly 2.24%, or 2.25 if you round it, percent. So this is Frank's interest rate. The bank's interest rate is 2.5%. So should he close his account and open a new one? If they will let him, yes, I would, because you get more interest. All right, and the final formula we are going to talk about today is going to be the continuous compounding formula. So this means that you're always accruing interest, so it's not like it's compounded quarterly, so once a month they give you interest. It's like it's constantly, you're getting interest based on the amount in your account. So the formula that we use here is going to be A of t is equal to P times e to the RT power. Now, P is your principal amount, how much you invested. T is the number of years compounded, or number of years the money's in the account. R is the interest rate. And E is an irrational number, kind of like pi. So we use E in this equation. And E is used in exponential equations. And what it is, really is, E is related to, now there's a lot of, like, I can go into it in pretty detail, but I'm not going to, but E is equal to approximately 2.7183, and it's used in compounding interest formulas. It's used in other formulas as well, but here, that will be, there's an E button on your calculator that you will use in this formula, and it is, let me find it, on the graphing calculators, on the TI 84s and 83s, it will be, if you go from the on button up 2 buttons to the LON, or the LN button, above it in blue, you should have E to the X power. So to get it, you would do second LN, and that will give you E, and that's what we're going to use in this formula. Okay, so now we're back to Sandy, and this time Sandy has the option of, what does she have the option of doing? Investing $10,000 into a continuously compounded account, earning 4.5% annual interest for 3.5 years. So we want to know what her accumulation will be. So we're going to start, and we're going to use our A of t is equal to P times E to the RT power. So this time, let's see, our principal is $10,000 times E, our rate, still 4.5%, but you have to use it as a decimal, so 0.045. And our time, again, is our 3.5 years, so we'll put our 3.5. All right, so what I'm going to do is I'm going to do 0.045 times 3.5, so I can get that decimal. All right, so this is what we have right now. We have 10,000 times E to the 1,575 10,000ths power, or 0.1575. So I'm going to do E first. So I'm going to raise it to the 0.1575 power. And that is going to give me 10,000 times 1.170580,758. And again, you don't want to round until the end. We're going to multiply that times our 10,000. And we end up with 11,705.80758, or if we're talking money, we're going to have $11,705.81. So if you go back and compare it to before, it is a little bit more than we had before. It's not, it's definitely more. So the more you compound, the more money you get. So it's better if you have the option and the same interest rate to get as, the account that compounds the most, so you earn the same amount of money or more money. All right, that's it for today, and hopefully you enjoy this lesson. Bye.